Now that we understand the basics of electrodynamics, we're ready to step into a very practical application: circuit analysis. Electrical circuits are a foundation of our modern lives. Everything that runs on electricity is in some way, shape, or form part of an electrical circuit. In this unit, we're going to look at the basic components that go into electrical circuits. We're not going to be able to get into the advanced components, things like diodes, transistors, capacitors, or inductors, which are really where computers and really larger power systems come from. The extent that we'll be getting into will allow us to examine circuits that have more to do with like in-home wiring. Regardless, we'll be able to learn some fundamental principles that will carry on to more advanced topics. So circuit analysis 1, our first step is being able to understand the language of circuit analysis. That language comes in the form of symbols. All electrical components have their own symbol. And the first one we need to understand is the voltage source. Symbols for voltage sources really depend on 1, which type of current you're looking at, and 2, which type of circuit you're trying to draw. The first type is the one that we're going to use most often. This could be represented as either a simple direct current power source, which would be like your cell phone charger, or as something as small as a battery. This symbol would represent an alternating current power source. This is more like the kind of electricity that would be coming out of your walls. We'll look at the difference between direct current and alternating current in a future video. This type of symbol is really for a specific kind of circuit drawing. So let's look at circuit drawings next to put these 3 drawings into context. Circuit drawings can come in a few different flavors, and that really depends on the specific application of the drawing. Some try to get extremely literal so that people who don't understand much about how to read a circuit would be able to still wire up a machine of some kind. But in general, this is the most common and the most simple kind of drawing that we would look at. We have our voltage source right here. These straight lines represent wires, and this squiggly line represents what's called a resistor. We'll look at those next. This is the next step up from that. These symbols right here are called the ground. You may have heard this term used in reference to electricity before. A circuit needs to be grounded in that it needs to have somewhere for excess electricity to go. What this really means is this component right here represents the common point where all the negative voltages meet up. That'll make more sense later as we understand how the current is moving through these circuits. The next one is just like the first one, just using our AC power source instead of a DC power source. Finally, this one is a little more advanced. It basically goes, you know what? We get it, there's some kind of voltage source. Instead of using all these different symbols, let's just make a point. We start here, we end here, so we can just draw things in a line and make everything nice and laid out. Nothing has to loop back around and connect. Now that we have a little bit of context, let's look at the different components that we'll be using in this unit. Right off the bat, we have wires. Electricity needs to travel through a conductor, so things aren't going to be able to move around if we don't have a wire connecting our components. Wires are just going to be a straight line. In any electrical diagram, if you just see a straight line, that represents a wire. We are not going to worry about the resistance of a wire in this unit. Lights. Very commonly, we'll be looking at things with light bulbs so that we can visualize what's happening in an electrical circuit. I'll actually be bringing some things in so that I can build some circuits and we can see what these actually look like. Lights have 2 symbols. One is kind of the official symbol. This is what you would use if you were more advanced, if you actually knew what you were doing. But people who don't take higher level of circuit analysis courses, they tend to draw light bulbs just like this because it kind of looks a little more like a light bulb. Sometimes they'll even go as far as actually drawing out a lamp and trying to draw something like that. We're not going to use these. We're going to use the official symbol. Resistors. Resistors are going to be our bread and butter here. These are going to be components in the circuit that take up some amount of electrical power. Now, we could represent light bulbs as resistors wherever we want, but this could represent all kinds of different electrical pieces of equipment. Things like speakers, or things like a computer, or anything that uses the power that we're putting into it. Resistors are most commonly symbolized by just this nice jagged line here. They can also be symbolized just with a block. This is more common when we're trying to use a resistor in a circuit just to represent something else. Like if I was going to be using light bulbs or speakers, but I didn't want to have to draw any extra components, and all I wanted to do was worry about the resistance of that component. I would draw it like this. We will be drawing them like this. That's the most common method. Finally, switches. Switches are very necessary in electrical circuits because unless we have a tremendous amount of voltage, our current isn't going to be able to jump through thin air. It needs to travel through a wire. So switches allow us to turn on and off an electrical circuit, just like the switches that turn lights on and off in your house. A switch is drawn with two little dots like this, and a line up like this when it's open. The same two dots, but the line drawn between them when it's closed. So this means open, and this means closed. Next, let's put some of our common components together and look at an electrical circuit. So, putting our most basic components together, we have a voltage source and resistance. This voltage source is going to push current through this wire and is going to be impeded by the resistance. We've already looked at the source of how these two things are related, and that's Ohm's law. Ohm's law, voltage is equal to current times resistance. So if I wanted to take this circuit and determine the resistance traveling through these wires, I would just use Ohm's law. My voltage is 12 volts. My resistance is 100 ohms times I. In order to determine the current, I simply divide both sides by 100 ohms. And that leaves me with 0.12 amps of current. Nice and simple. Going forward, we'll be able to build more complex circuits and see how things like multiple resistors interact with each other, what laws govern how current moves through wires like this, and what happens when we have things like multiple voltage sources or different current arrangements.